Hello viewers, Alan here. Thanks for joining me again in the workshop. So pressing on with the Lynx engine, I'm going to do the cambox in this episode. And when I looked at the drawings, it didn't seem that complicated, and it probably shouldn't have been. But I made plenty of mistakes. They're included for your entertainment, and also the fixes for your edification. But I better just dive straight in, and let's get started. So I'm going to make the cambox out of this piece of aluminium, or a piece of this. This is actually a piece I've had for quite a while, and I've used it for a number of individual projects actually. I might just show you a couple of them. It's 25 by 50 aluminium. I don't know what sort of aluminium it is. I don't know that it's 6061, but it does machine nicely. So I picked that bar up as an offcut somewhere. It wasn't very expensive. And I've made a number of these sort of blocks out of it when I was plumbing the workshop for compressed air. I couldn't find an air distribution system that was at a price I was happy to pay, so I decided to make my own. So I made these aluminium block, and this line was from it's an auction buy, about 100 metres or something, of this 3/8 diameter nylon air line. I think it was used for truck brakes or something. Anyway, I made several of these in different configurations, and they've proved to be really quite successful. I made this distribution system, I don't know, 5 years ago or something, and really had no issues with it at all. Before starting to mill the cambox from this bit of aluminium, I wanted to make sure I had the mill correctly trammed. And in particular, I wanted to set the tram in relation to the base of the vise here. So I've got these actually precision 1, 2, 3 blocks. I've got a pair of them, one each side of the vise, and this is the faceplate from my Hercus lathe sitting on those blocks. And I found that it was relatively easy to tram the head. So I think I'm within 0.01 always all around, so which is as good as I could hope to get. And checking it another way, you can see it's pretty good. Okay, so we'll start by squaring this block up. Oh, that looks pretty good. I'll turn him around, do another side. That's another nice finish. I'll just whip it out and just check that both ends are the same thickness. So I'm going to leave this at 31mm for the moment. The finished size is 30, but the box will be made up out of 3 pieces, the guts of it, a lid and a front piece. And my thinking is to bring the overall width to size with the lid and the front piece on, so the sides all line up properly. Well, that's the plan. We'll see how it works out. So for now, I'm going to square off both ends. Well, that looks pretty good, so I'll take it out and check the dimensions, and then probably clean the face sides up. This cutter's doing a pretty good job. Right, well, that's cleaned it up all round, all 6 faces, and squared it off. I think now I'll bring it to the thickness of which is the height of the box, which is 21.7, but I'll leave myself a margin, I think, to clean up after I've done all the other machining. So I'll bring it to 22, which will leave me 0.3 to take off later. I'm not sure whether I'm going to regret that, but that's the current plan. So let's lop about 3mm off. So with the block out of the vise, I can do a proper size check and compare both ends. We've got 22.013 up that end. hopefully somewhere near it up this end. 22.012. Oh, well, I'm pretty happy with that. Right, so I cut that off in the bandsaw, and I always have low expectations for the quality of cut I'm going to get from that. It's quite a cheap saw, but on this occasion it surprised me. And you can see that's actually a straight and square, and straight and square that way too. It's surpassed itself. Alright, that's my two pieces, so that's going to be the front, and this will be the main body. So I'm going to start by bringing the cambox main body to length. It's currently on 40 or thereabouts, and I've got to come down to 36.5. So I'll just lop a bit off. That's good. Let's do a proper size check. Unfortunately, I've only got an imperial depth micrometer. So let's do a bit of conversion. Okay, let's see what that is. So checking the length of the block after that final machining, we've got 36.45. We were shooting for 36.5, so I guess we've got to be happy with that. I'm only using the calipers because it's easy to read them, but I also checked it with that depth micrometer and it confirmed the same story. So that's where we're at. So this front piece, when it's machined, will have a projection on the back which will be housed within the body, within the main body, and that feature is nominally 14 millimeters wide, but I'll machine it to exactly fit the width of the projection on the underside of the head, because that's what this body will actually have to sit over. Hopefully it will become clear as we move along. Anyway, what I want here is a trench across here, 1.5 deep, and the width of this piece. My first pass will be with a depth of cut of 1 millimeter. So I'm going to clean this up and then check the width accurately to work out how much I've got to take off each side to get the fit I want. Right, well, that's a 12.68 gauge block stack. 12.69 wouldn't go in, so I think it's 12.68. Given that I was using a 1/2 inch cutter, it's surprising that it actually went undersized on 12.7, but nonetheless it did. So we're on 12.68, and so now I can work out how much to take off each side. Okay, well you won't probably be able to see how well this worked out, but that's actually pretty much exactly the fit we were looking for. It will slide, you can't rotate it at all. So if I get the projection on the back of this front piece to be the same width as that, we're going to be in good shape. So there'll be a final pass here on each side, which will create the projection on the back of the front cover. Right, so does this fit? Oh yeah, it's pretty good actually. Yeah, that's gone down properly. There's a slight gap there, and that's deliberate. I made the hole 1.6, and the dowel, if you want to call it that, is 1.5, so that's why there's a hairline across there. One of them had to be shorter than the other. I actually think that snug fit's going to be alright, because this is the body and that's the front cover, and I'll drill a hole pattern through the front cover into the body, and then this becomes the locating feature, because the front cover will have a bearing mounted in it and another bearing at the back, so we want everything to line up. So the fact that that's a really close fit in there, I think that's probably a good thing. Well, I didn't do a spectacularly good job of deburring the thing, but you can see the two pieces do fit together pretty well. So anyway, the next thing is to do a hole pattern, bolt pattern into the cover. So I've drilled and tapped holes for 4 3mm screws to hold that end cover on. Now I'm going to drill through it and create the centre bore, which I'll use for aligning all the other pieces of this. So I'm going to put a 9mm drill through, and it has to go down to within 0.5 of the bottom, and then I'll open that hole out to 10mm, and then the rest of the bores for the bearings and everything else I'll use that 10mm bore as the datum for those subsequent processes. Well, let's see how we go. Get rid of some of this swarf. So we're now down to within 1mm of the bottom, so I'll clean this lot up and switch over to a 10mm end mill. So I've changed my mind about using an end mill, for the most part anyway, so I'm going to use the boring head, so I'll need that later on anyway. So what I'm going to do first is a bit of a sighting pass to get it to calibrate the size it's cutting at. And to get dialed in, I've got a 3/8 dowel pin here, and I've got the boring head calibrated for that, so I know what my starting point is and how much I have to take out to hit 10mm. Let's see what the micrometer thinks we've got. Right, we're on 9.71. So let's start the checking with a 10mm dowel pin. That's saying the hole's slightly undersized. It would push in, but it's a bit tight. Well, let's see what the micrometer says. Well, micrometer thinks we're right on the money. Let me check the size of the dowel pin. I think that's our explanation. The dowel pin is slightly oversized. So I think we must be pretty much on 10. I'll see if I can find a dowel pin that's closer to 10, or maybe even marginally under. So I think this is a better candidate to use. Let's see what this one looks like. Alright, well this on size dowel pin, it will go in just. It's quite a snug fit, but that's alright. So that hole must be right on size at 10. So now I just have to clean up the bottom of the hole, and I think the best option for that is a 3/8 of an inch slot drill. It will at least reach to the bottom, but to try and use a 10mm one, it would bind up on the sides. Yeah. Right, I've got 2 more features to do here. So the first is this larger diameter that you can see. I'm trying to get that to 16.5, 30mm deep, and that'll provide clearance for the rotating cam lobes. And then somewhat more challenging, on the bottom of that bore, I have to create a 12mm bore, about 4mm deep, as a bearing fit. So that's going to be a bit of a challenge. I'm not sure yet exactly how I'm going to do that. But anyway, to do the easier bit first, well, I'm not sure what I did wrong there, but I've managed to overshoot by 0.05. So I finished up on 16.55. That's not fatal for this diameter. It's after all just a clearance for the camshaft lobes, but it's not going to be anywhere near good enough for the bearing fit I need to get at the bottom of the hole. So I think I have to do a bit more practicing. So I've spent a bit of time thinking about how to do the blind hole in the bottom of this camshaft housing. It's about 40mm down, and my original thinking was to use the facing feature of the boring head, but I decided to make my life a bit simpler, and I've reground this cutter so it's flat across the bottom, because there's already a 10mm pilot hole at the bottom, and I just have to open that 10mm pilot hole out to 12mm for a depth of 3.5 to take the bearing. So in other words, I don't have to take a lot of material off across the bottom. So what I'm going to do, or what I did here, was to take 2 passes. First pass took me down nearly to depth and 0.1 short of the required diameter. Second pass was the finishing pass on size for both diameter and depth. And it seemed to work out alright. I've had this bearing in and out of this socket a couple of times now, and I think you'll be able to see that it's quite a snug fit, and just the fit that I'm looking for. So I've got a recipe that I used to do that. Hopefully the same recipe will work here. Well, it's time to find out. Well, I managed to mess it up again and bored an oversized hole in the bottom of this thing. To explain what happened, I had the boring head set up so that the cutter would move inwards when I was doing the facing operation. And of course I decided not to use the facing operation, but I left the cutter there. But the consequence of making the cutter move inwards is that the arrow, you have to turn this adjuster in the opposite direction. So when I was doing the sizing for the hole in the bottom of this, I forgot about that and turned this darn thing in the wrong direction. So I finished up with a hole that was oversized. However, to avoid scrapping this part, I come up with a cunning plan. So I machined up a collar for the bearing. That allowed me to get the bearing fit that I wanted within the collar quite easily. And I've set the size of the collar, the OD of the collar, to be most of the diameter of the hole. So I've machined a recess in the bottom of this camshaft box, and I'm pretty sure it's the right size for that to be a light press fit into. And I just put a drop of Loctite on that and hopefully retrieve the situation. And I made an installation tool as well, which allowed me to press the bearing with all of the force, not there'll be much of it, acting on the outer ring of the bearing, not on the inner race. So it won't be putting any pressure on the balls, because in this bearing this size they're not very big balls. Anyway, let's see if I can make this happen now. Get a little bit of the green Loctite on it. That'll be more than enough. Right, well, fingers crossed. I didn't tighten the bloody thing up, idiot. Right, well, I think for better or for worse, it's in there. Hopefully you can see the bearing in the bottom of the hole, and it all seems to be fine. Right, and the top face of that, what's now the collar, which would have been the bottom of the box originally, is supposed to be 30 from the top. Well, I'm on 30.18, so I'm happy with that. So I reckon we can call that a successful save. Of course, it would have been better if I hadn't messed it up in the first place, but there you go. So now I have to do the same thing, mount a bearing in the same way to the inside of the front cover. So I have to do a counter bore there. So that's next. Alright, well, let's see if I can bring this to a good fit for a 12mm bearing. And this cut should get me pretty close. This is a size guide I made up previously, and if this is a sliding fit in the hole, we're going to be right on size. I could push it in, but I don't want to do that, so I think I need to go just slightly larger. So I decided to take a cut at 0.005, or half of one of my index marks, is basically amounts to going down at the same setting, I suppose, but I think it will just make it just slightly looser. Right, let's try my size gauge again. It should be just a slight bit looser this time, hopefully. And it is just slightly looser. I think that might be just what the doctor ordered. So I machined up this installation tool with an 8mm nose and with a size that was just right to hold the bearing but not interfere with anything. There's no doubt it's going to go in. I just have to gauge the pressure required to push it in. It's not taking much. Whether I can push it the rest of the way with my thumb. No. So it might still be tighter than I would have liked. It didn't take much pressure. I think that'll be fine. Now, because I regard this as a scrap bearing, I don't have to worry about damaging it when I try and pull it out. So I think you could probably see from that the bearing fit in there is perfect. It's going to be held very nicely and I'm not going to worry about Loctite. I'm getting set up now to machine a slot in the bottom face of the cam box. Eventually that slot will reach through into the camshaft bore, but initially I want to be very careful about how I do it. I want to get the best fit I can with the protrusion that's on the top face of the cylinder head so I can use it as a locating feature for the bottom of the cam box. Now the drawing calls for this to be the slot to be 30 long, but in my case that would take you to the bottom of the box as the bottom of the camshaft bore, but in my case you'll recall I put in that collar to make up for the mistake I made with overboring the hole, and anyway it finished up about 0.1 higher than it should be. So what I'm going to do is cut this slot initially at about 2.5, which is the depth of this thing, and that will allow me to prove the fit. But the slot will probably go further than the front face of the bore as it now is, but above it. So anyway, I'll then be able to see how to do the rest of the machining to make sure I don't hit the bearing that's in the bottom here. That might all make a bit more sense when we get further into it. But to start with, I'm using a 12mm cutter and I'm going to go at a 1mm depth of cut to make this 30 long trench or slot. I forgot to tighten this darn thing up. Oh yeah, I'm hopeless. Oh, that's looking good. So we come down to 2.5 deep now. So I stopped with 0.5 millimetre spare at the end for a clean up. As now I've got to get the width correct, obviously, and clean these corners out quite a bit more. Okay, so I'm going to do another pass around the sides, and this should be bringing me pretty close to width. So I've just had my lunch, and while I was eating my sandwich I realised I could actually safely go quite a bit deeper around there and cut that piece out. So that's what I'm going to do now, or try to do. So that was a 2mm depth of cut. Should have taken a lot, but not all of the piece out. So it's certainly taken a lot of it out, and I can see where that bearing is properly now. Bearing's actually sticking out a bit further than I thought it was going to be, unless there's a big burr there. I've worked out what's going on, why I'm seeing so much more material at the bottom than I was expecting. Basically I used the wrong dimension. When I was boring this original 16.5mm hole, I took the wrong dimension from the drawing, and I finished up 1.5 millimetres shallower than I should have been. So I've aligned myself on the original 10mm hole in the bottom here, as you'll see. So that alignment hole, I think, will allow me to preserve the correct alignment of the bearings. And I have to bore down now to house this, another one of these things that I've made with a bearing with a collar. I've got to bore down to within 0.5mm of the bottom of this cam box, and then fit that. So that's what we've got to do, and hopefully that will retrieve the situation. I suddenly encountered more resistance there. Okay, worked out where that resistance is coming from. The original ring that I Loctited it in has come loose and is turning with the boring bar, so I'll have to try to get it out. Well, it looks like I've made some progress with that. Yep, there it is. Hopefully I can continue the boring now. Right, well, let's press on towards 0.5 off the bottom. Okay, now I've got the bore sorted out. I'll cut the slot on the other side of the box. Right, well, that's created a 12mm wide slot. I've got to open that out both sides to 14. Just as a footnote, I actually had the front cover bolted on upside down to hold the spacing of these legs. When I take all this material out of there, I didn't want the vice closing them up. Anyway, I've got to take about 1mm off each side. Alright, I just have to change to a smaller cutter to clean those corners out. So now I want to bring the body of the cam box to height. Looks like we're on 856. See what that is in millimetres. Right. That's 21.74 and the nominal height of this thing is 21.7, and the only thing that sits on here is the lid, so I don't think it's worth chasing that last 0.04. So we'll call that done and start working on the lid. The top cover is called out to be 3.2mm thick, which is obviously just a hair over 1/8 of an inch, and if I'd had 1/8 of an inch material I would have just used that, but didn't. So my best option was to skim down a piece of 6mm thick bar, which is what I'm doing here. So as long as that's finished up somewhere near 3.2, I'll be happy. Well, finished up on 3.21, which is pretty good, and certainly close enough for a piece of metal that's just going to be a lid. Nothing sits on top of it or anything, so we can start knocking this thing into shape now. Alright, so it's time to mount the cam box on the cylinder head. Now, when I was machining the cylinder head last time, I drilled and tapped the mounting holes for the cam box, so hopefully when I drill through it, it'll be to find those holes. Now, I have been able to preserve a very close fit of that on there, and in fact when I do these tighten up the screws on the front of the cover, that's on there. Certainly going to resist any movement from a 3mm drill. Okay, well, let's get set up for drilling the holes, and hopefully they'll line up with the holes in the head. Alright, here we go. 3mm hole, 21.7, and hopefully we'll stop at the cylinder head interface. Well, here we go. Well, that's 21.7, which is the depth of that. Alright, well, let's take the drill out. And see if it's found a hole. I haven't got any screws the right length for this, but just see whether how about that? That's actually screwing in. Might need to do a little bit of a clean up at the interface. Actually, I might just check out the alignment of that before I go any further. Yes, I think the drill hadn't come completely out the bottom. So the screw might go in a bit easier now. Just get a what do you call it? Countersink. Try this screw again, see if it goes a bit easier this time. It might be that I just need to clean the top of the hole, the threads at the top of the hole out a bit. Actually, the problem was the threads on the bottom of the screw were a bit dirty. So that's surprisingly well aligned. This screw is quite long, but looks like it might actually be usable with the thickness of the cover goes on. Anyway, we'll leave him in there for the moment. Move on to the next hole. Right, now we'll find out whether this one lines up. Might not have gone deep enough. That's the problem there. Didn't come all the way through. Right, so I'll clean the threads up on this screw. Let's see if we struck gold again. Oh yeah. Yeah, that's good. Happy with that. Alright, well that's 2 from 2. I'll bring you back when I've done the other 2, and hopefully it will be 2 more success stories. Fingers crossed. Right, well, all 4 of them went in, and they're all finger tight. So the alignment's pretty darn close, and it's something of a miracle really, because I drilled 3mm holes, and the screws have got a 2.94mm shank. 2.92 is it? Well, something like that anyway. So there's very little play. That's pretty darn impressive. I think that's hats off to the DRO. Anyway, so that's that part of the deal done. Now I've got to work out how to map this hole pattern through into the lid. Right, so I feel like I'm making a bit of progress now. As you can see, I've got the lid made and fitted. So that finishes the structure of the cam box. Right, so what's left to do now is to cut the grooves which will create cooling fins on the sides and the top, and I'll be using this cutter for that, a bit oversized for the job from a diameter point of view, but it's the only cutter I've got that's the right thickness. Anyway, let's get set up and get stuck into doing that, and then I'll get this cam box finished. So first step in cutting the grooves to create those cooling fins is to knock these back corners off to create 3mm flats. So to help myself do this, I made up on a bit of scrap a backing plate so I can screw the 2 bits together and do that chamfer on both pieces at the same time. Well, I did that in 2 passes because I was going 1.5mm deep, but it did so easily. I think I'll do the other corner in 1 pass. Right, so set up now to cut the grooves. They were 2mm wide by 2mm deep, and there's 4 of them. Well, I think it's turned out alright. Put it out, clean it up, and do the top. Right, well that's hopefully finished the machining on the cambox cover. It's just a big clean-up time. Right, well I'm quite pleased with how that turned out in the end for all the trials and tribulations. As I mentioned in the video, it was a goal to have the opening in the bottom of the box, a good indexing fit on this raised lump on the top of the cylinder head, and that will guarantee that the camshaft will run parallel to the crankshaft. So that was good. Didn't get as far as I had wanted. I sort of did dream about getting the camshaft done as well in this video, but that's for the next one. So hopefully you'll join me for that. Cheers and thanks for watching.